built the first ever electric all-terrain vehicle from Kerala to qualify for track racing in terrain vehicle motorsports. Preferred recruitment destination for many prestigious companies like Infosys Limited, Amazon, IBM, TCS, MRF, and Indian Navy. The most beautiful moments in one's life are born on campus. At St. Kitts, life beyond academics is full of possibilities. The popular fests of St. Kitts, Nakshatra, Synthesis, and Kitts Blitz reflect the spirit of the youth. Hostel facilities for all. A home away from home. Chase your dreams, pursue your passion, and define yourself at St. Kitts. We at St. Kitts believe that greatness is already within you. We will help you bring it out because we are equipped to do so, and we genuinely care about you.
Good morning, Dr. Murty, sir.
Good morning, everyone, friends.
I am MD Matthew here.
Hi, hi.
Good morning, ladies and gentlemen. Welcome to the fourth series of our short-term training program conducted by the Department of Mechanical Engineering and sponsored by AICTE. As you all know, we had successfully completed the three series in past 3 months, and finally we are here with the fourth series. As you all know, we are having a 6-day training, short-term training program, which will be beginning today and will be ending on the 28th of November, which is Saturday. We have some of the most renowned speakers from our globe, and today we'll be beginning with the inauguration at just a few minutes later, and followed by the first speaker, Dr. Jitendra Kumar Kartyar. And the inauguration will be done by, inauguration and the inaugural address will be by Professor Dr. B.S. Murty, the Director of Indian Institute of Technology, Hyderabad. Then the slow 2 is handled by Dr. B. Keshavan, who is the Assistant Professor in the Department of Mechanical Engineering at Indian Institute of Technology, Palakkad. He'll be handling the topic Tribological Behavior of PTA, Deposited Hard Phasing Alloy. Tuesday, which is tomorrow, we'll be having 3 slots, that is starting at 9:30 a.m. We'll be having Dr. Deepak G. Dilip from the Department of Mechanical Engineering of Ma Baselios College of Engineering and Technology, Trivandrum. He'll be handling the topic Application of Optical Profilometry in Surface Characterization. The slot 2 is from 11:30 a.m. to 1:30. Which will be handled by Dr. A.P. Harsha. Then the third will be by Dr. Ravi Kumar Dumpla on surface characterization and tribological aspects of CVD diamond coatings. Then the third day is Wednesday. As on Tuesday, we are having 3 slots. The session 6, 7, and 8 will be handled by Professor Dr. N.D. Matthew in 9:30 a.m. Then by Professor Dr. Satish C. Sharma from 11:30 to 1:30, and finally by Dr. Chimmaya Kumar Saho from 2 p.m. to 4 p.m. On Thursday, we'll be having 3 slots. The first slot will be handled by Dr. Jeetu S. Babu on computational methods for nanoscale system, followed by Dr. U.B. Jaydeep, and finally by Professor Dr. Mamala Ravishankar from 2 p.m. to 4 p.m. On Friday, which is the second last day of this STTP, we are having 3 slots. Usually from 9:30 to 11:30, we are having Professor Dr. Soni Verghese, followed by Professor Dr. A. Elaya Perumal from 11:30 a.m. to 1:30, and finally by Dr. Subjit Baumik from 2 p.m. to 4 p.m. The Saturday is the final day of this 6-day short-term training program. The first slot is from 11:30 to 1:30 p.m. by Dr. Basil Kuriachan on surface integrity and tribology of electric discharge quarter TI-664. And the slot B is from 2 p.m. to 4 p.m. As you all know, it is an online assessment test followed by the valedictory function. So this is a briefing of our short-term training program. We'll be beginning our inauguration in few minutes. Thank you.
Thank you, Grishma, for the briefing. So we will start our inauguration schedule. Matthew, sir?
Yes, please.
Yeah.
Yes, sir.
Grishma, you can proceed. So good morning to all. Professor B.S. Murty, Principal of the St. Kitts College of Engineering, Professor N.T. Matthew, Dean Research of St. Kitts College of Engineering, Colonel B. Venkat, Director, Faculty Development Cell, AICTE, New Delhi. So it's an extreme pleasure to have the 4th series on time. So we will formally start our inauguration schedule with a silent prayer. Thank you all.
Now, hello, sir. Am I audible? I'm sorry, I just got disconnected.
Yes.
Okay, I'm sorry.
Yes.
Now, to present the welcome note, I happily invite Professor Dr. Jacob T. Verghese, Head of the Department of Mechanical Engineering of St. Kitts College of Engineering.
Can you hear me?
Yes, sir, you are audible.
Yes, very good morning. Greetings from the Department of Mechanical Engineering at St. Kitts College of Engineering, Kerala State. I'm Jacob Verghese from the desk of the Head Department of Mechanical Engineering. And officially, I am assigned with the great responsibility to welcome everyone to the 4th series of this short-term training program on recent advances in tribology and surface engineering. I directly step into my responsibility now. First of all, at St. Kitts, we have the most respectable person, Sri Thomas T. Johnson. He is the director of the St. Kitts Group of Institutions. With great respect, I cordially welcome you to this inaugural program of the AICTE-sponsored STTP, organized by the Department of Mechanical Engineering, St. Kitts. So welcome, sir. The Executive Chairman of St. Kitts Group of Institutions, Engineer Kunuz George, sir. He is the standing support to everyone at St. Kitts. And with great pleasure, I extend my cordial welcome to you. We have with us an important person of the state, Colonel B. Venkat. He is the Director, Faculty Development Cell at AICTE, New Delhi. He was instrumental in sanctioning this particular STTP series to the Department of Mechanical Engineering at St. Kitts. So it's a great honor to have you here today. And with great pleasure, I cordially welcome you to this inaugural program. Now, I'm extremely honored to welcome the great person and in fact the prime person of the day, our chief guest, who is about to inaugurate this AICTE-sponsored STTP program. It is none other than Professor Dr. B.S. Murty, the Director, Indian Institute of Technology, IIT Hyderbad. He is the chief guest of this inaugural program. And in spite of other numerous programs that he has to attend today at IIT Hyderbad, he accepted our invitation and has given his consent to inaugurate this STTP organized by the Mechanical Engineering Department. So, sir, with great honor, I welcome Dr. B.S. Murty, sir, to this inaugural program. Here at this moment, we recognize the presence of our principal, Dr. Joseph Kunyivolsi, our vice principal, Professor Koshi Wargis, the management member, Dr. Mini Punus, our dean research, Dr. M.D. Matthew, the registrar, Dr. Muruganandam. We cordially welcome you all to this inaugural program. Before I conclude, there are a few more groups to be welcomed. We have more than 525 registered participants from all over the country. And we in fact recognize the presence of a few participants from foreign universities as well. And these participants encourage us a lot. I extend a warm welcome to all the participants. Our colleagues from the various departments at St. Kitts, in particular, all the faculty and staff at the Department of Mechanical Engineering are cordially welcome. At the end, the coordinators of this program, Dr. Jason Cherian Isaac, the Professor, Mechanical Engineering Department, and Dr. Chakoprana Koshi, Associate Professor, Mechanical Engineering Department, are cordially welcome to this program. I conclude my part. Stay connected throughout the program. Stay safe and healthy at the place you are. And thank you very much.
Thank you, sir, for your kind words. Now, to brief you about the fourth series of our STTP, I invite Dr. Chako Pranav Koshi, who is the coordinator of this STTP. Over to you, sir. Sir, could you please unmute your mic? You're not audible.
Thank you. Sorry. Thank you, Grishma. Respected Sri Thomas T. John, Director, St. Kitts Group of Institutions. Chief Guest Professor Dr. B.S. Murty, Director, Indian Institute of Technology, Hyderabad. Guest of Honor Colonel B. Venkat, Director, Faculty Development Cell, AICTE, New Delhi. Engineer Punus George, Executive Chairman, St. Kitts Group of Institutions. Dr. Joseph Kunyivolsi, Principal, St. Kitts College of Engineering. Dr. M.D. Matthew, Dean Research. Dr. Jacob T. Varghese, Head, Department of Mechanical Engineering. Dr. Jason Cherian Isaac, Professor, Department of Mechanical Engineering, STTP Coordinator. Distinguished professors, ladies and gentlemen, a very warm welcome to St. Kitts College of Engineering. It is my honor and pleasure to address you regarding the AICTE-sponsored online short-term training program on recent advances in tribology and surface engineering 404 with specific topic surface characterization and treatments in tribology, scheduled on 23 to 28 November 2020. The current wave of globalization is taking place precisely because it is part of the beginning of the era of knowledge-based society and economy, in which knowledge is the only meaningful factor of production and other factors are secondary and can be obtained easily provided there is knowledge. My present duty is to give you a brief introduction about the STTP series on recent advances in tribology and surface engineering. First of all, as already informed by the head of the department, we are glad to inform you that we have received more than 525 applications across the globe for the STTP. The STTP series consists of 4 schedules in the month of August, September, October, which was completed successfully, and November 2020 currently scheduled. They are divided based on the content of the main topic of the STTP as mentioned below. The series 1 is Introduction to Tribology and Surface Engineering, scheduled during the August. Series 2, Tribology of Machine Components and Applied Tribology, scheduled during September. Series 3, Introduction to Special Topics like Nanotribology, Biotribology, and Space Tribology, scheduled during the second week of October. And Series 4, Surface Characterization and Treatments in Tribology, scheduled during this week. Sequence of friction, wear, and lubrication is referred to as tribology. The term tribology is derived from Greek words tribos meaning rubbing or attrition and logi meaning knowledge. So the literal translation would be the science of rubbing. Importance of tribology for sustainable reliability cannot be overemphasized. It is reported that loss due to improper understanding and application of tribology is over 1.5% of GDP of the developed countries like USA. We can well imagine the state of affairs in our country, where awareness about importance, understanding, and application of tribology is rather low. Tribological failures are responsible for over 40% of breakdowns in industries. Therefore, engineers working in the field need to have a thorough understanding of tribological practices so that proactive measures can be implemented in place of traditional corrective and breakdown maintenance practices. The history of tribology is as old as history of mankind, the main driving force being the facilitation of daily activities by reducing friction. Tribology is multidisciplinary in nature and includes mechanical engineering, material science with research into wear resistance, surface technology with surface topography analysis and coatings, and the chemistry of lubricants and additives. The relatively younger disciplines of tribology are biotribology and nanotribology, as well as space tribology. The aim of this program is to provide a platform to academicians, practicing engineers, R&D professionals for sharing their knowledge and experience in this field. The program is intended to provide an international platform for interaction between renowned tribologists of the globe and the participants, comprising of teaching professionals, research and PG scholars, and practicing engineers from industries. Also, this program intends to identify the areas where current research is being focused to promote its viability. The core course content includes basics of tribology, basics of fluid film lubrication and hydrodynamic bearings, lubricants, tribology of machine components, applied tribology, and some special topics including nanotribology, biotribology, space tribology, and tribology at extreme environments. It is with this background that the Department of Mechanical Engineering, St. Kitts College of Engineering, Kottayam, is organizing the STTP series on recent advances in tribology and surface engineering during August, September, October, and November 2020 at our prestigious institution to reinforce the need for continued education in tribology and interdisciplinary science and technology of friction, wear, and lubrication. Lastly, I, on behalf of St. Kitts College of Engineering, wish all the participants a fruitful week to nurture your career for spreading the word tribology across the globe. Thank you very much indeed.
Thank you, sir, for that briefing. Now, to present the presidential address, we have Sri Thomas T. John, Director, St. Kitts Group of Institutions. Over to you, sir.
I'm very happy that...
Grishma, is it audible?
Yes, sir, it's audible.
I mean, Thomas sir's words?
Yes, Thomas sir's audio. Yes, sir, it's audible.
No, now it's not audible.
The department has conducted so far 3 series on and surface engineering. And the fourth series, the topic is surface characterization and treatments in tribology. As you are aware, tribology has become an integral part for the sustainable environment as it helps to conserve energy and improve efficiency and industries, improve efficiency of industries all over. Through this program, we hope to increase awareness about tribology and its importance and promote discussions and research in this field. I congratulate the Mechanical Engineering Department, its faculty, and especially Pranay Koshi for organizing this very vibrant and important program.
Thank you, sir.
Well, that was our director, Sri Thomas T. John, sir, now we will be moving. Yes, to address the guests and participants of this STTP, I call upon Professor Dr. Joseph Kunyipolsi, the principal of St. Kitts College of Engineering. Over to you, sir. Sir,
Yes,
you are
yes, sir,
you are
can you
muted.
unmute?
Sir, could you unmute yourself?
Am I audible now?
Yes, yes, sir, you are audible. Yes, sir.
Yeah, I'm unmuted first, and I don't know what happened.
Okay,
okay, sorry.
it's okay.
President of the function and respected director of our college, Thomas T. Jones, sir. Respected executive chairman, Sri Punnus George. Guest of honor, Professor B.S. Murty, director, IIT Hyderbad. Guest of honor, Colonel B. Venkat, director, faculty development cell, AICTE. Head of department, Dr. Jacob T. Varghese. Dean Research, Matthew Sir. Coordinators of the program, Dr. Jason Jerry and Isaac and Dr. Jacob Koshi. Faculty members and dear participants, fine good morning to all of you. I'm really happy to notice that the mechanical department of our college is organizing the 4th FDP program in a series of FDPs. And we have already successfully conducted 3 FDP programs on the same subject in a row, which was received with an overwhelming response from faculty members from various parts of the nation. As all of might be knowing, any system is devised or designed to have a maximum efficiency as far as possible, to design and get the maximum efficiency. As far as a mechanical system is concerned, the efficiency can be increased. The efficiency has to be increased. The friction losses has to be minimized as far as possible. So, as all of you might be knowing, the friction losses is one prime importance of reducing the friction losses is by applying suitable lubricants. And the lubricants can be either a solid lubricants, liquid lubricants, or in certain cases, even gaseous lubricants are also applied. But that depends upon the system and the material on which we have to decide which lubricant has to be used. And again, the solid, liquid, gaseous itself can be of different categories. And one important criterion or a characteristic of the lubricant is that it should not in any way react with the material and it should not harm or the material. There should not be any loss to the system as such. So the detection or the selection of a suitable lubricant for a mechanical process is really important. In addition to reducing the lubrication, when a wear and tear occurs, in addition to the loss of the components, there are a lot of carbon also will be emitting, which further augments the pollution as well as the carbon output that will be supplied to the atmosphere, and all those difficulties will be there. And again, when the wear and tear occurs, the parts has to be replaced all on a sudden. Frequent replacement will occur. That further augments the increase in cost of the things like that. In addition to this, in addition to the lubrication, the surface characteristics of the material are also rather important, because many of the functioning of the system is dependent upon the surface roughness or the surface finish of the system. But there should be a compromise between the surface roughness and the surface finish. Even though when increasing the surface finish, the lubricant, the wear and tear can be reduced, but we cannot reduce the wear and tear, so we cannot increase the surface finish beyond a certain extent, because it will be leading to certain other problems also. So there should be a compromise between the surface roughness or the surface finish that can be provided to various components. That's also require a thorough study. So the topic that is selected for the short-term course, tribology and surface engineering, is a very important subject, or it is very much relevant to the mechanical engineering field nowadays. And as I understand, there are participants as well as resource persons are drawn in from various reputed institutes, and they be having a very good knowledge about the things. Like our own Dr. B.S. Murty, who is the director of the Indian Institute of Technology, Hyderabad, who is going to inaugurate the function, is a very well versed professor in the field of typology. And we would be happy to hear from persons like B.S. Murty, and we are drawn the resource persons from reputed institutes. And I hope the participants will be benefited by this short-term program, and I wish the program more success. At the outset, I wish to congratulate the Mechanical Engineering Department, especially the coordinators of the program, Dr. Jason Jarian Isaac and Dr. Jacob Koshi, in organizing this FTP program, which is very much relevant today. Thank you.
Thank you, sir, for your kind words. Now, the time has come for the inauguration and the inaugural address. For that, we have Professor Dr. B.S. Murty. So, Professor Dr. B.S. Murty is an Indian Institute Professor and Girija and R. Muralidharan Chair Professor at the Department of Metallurgical and Materials Engineering of IIT Madras in India. His academic journey started with a diploma in metallurgy in 1983, followed by BE from VRCE Nagpur in 1986 and ME from IISc Bangalore in 1988. He obtained his PhD in the year 1992 from IISc Bangalore. After serving at IIT Kanpur for 12 years, Kharagpur for 12 years, he has been a professor at IIT Madras since 2004. He is also currently an adjunct professor at Ryerson University of Toronto, Canada, since 2011, and also an associate faculty of School of Engineering, University of British Columbia in Canada from 2016. His fields of interest are high entropy alloys, non-crystalline materials and nanocomposite, bulk metallic glasses, grain refinement and modification of aluminum alloys, aluminum-based composite, in-situ composite, non-equilibrium processing, particulate technologies, thermodynamics and kinetics of phase transformation, electron microscopy, atom probe tomography. He has authored about 400 journal publications and 4 books. He has supervised 39 PhDs and 20 PhDs are ongoing. He has completed over 55 sponsored research projects and currently handling 13 projects and filed 20 patents. His main research contributions are as follows. He has pioneered the field of non-equilibrium processing of materials by mechanical alloying. He has not only developed advanced materials using his root, but also has made key contributions to the development of theoretical framework in his field. He has developed a wide variety of nanomaterials with exceptional structural and functional properties and demonstrated their technological viability. He has made significant contributions to the field of bulk metallic glasses, including developing thermodynamic models for predicting glass forming ability. He has also pioneered the field of high entropy alloys, which are existing new class of materials with immense application potential. His group is the first in India to successfully develop a technology for the production grain refiners for aluminum and demonstrate their superiority over the imported ones. Under his leadership, a national facility for atom probe tomography has been set up at IIT Madras with a remotely operable local electrode atom probe that can characterize materials in 3D at the atomic scale. He has also set up Deakin IITM Center of Excellence on Advanced Materials and Manufacturing at IIT Madras jointly with Deakin University of Australia. He is a recipient of numerous awards, including Shanti Swar Bhatnagar Award in 2007, J.C. Bose Fellowship Award, INAE Outstanding Teacher Award, Honorary Doctorate from Deakin University, Lifetime Achievement Award of IIT Madras, G.D. Birla Global Medal, Eminent Material Engineer Award, Distinguished Alumnus Award of VNIT, Metallurgist Award of the Year, then MRSI Medal, INA Young Engineer Award, INSA Young Scientist Award, Young Metallurgist Award in the year 1994, and ISCA Young Scientist Award. He is a fellow of the World Academy of Science, Andhra Pradesh Academy of Sciences, Indian Institute of Metals, Asia Pacific Academy of Materials, Indian National Science Academy, ASM International, Indian Academy of Science, National Academy of Science, Indian National Academy of Engineering. It's an honor and privilege to have you here, sir. So I call upon Professor Dr. B.S. Murty for the inauguration and inaugural address. Over to you, sir.
Thank you, Greshma. I never thought that this introduction will be this long. You should have told me before.
Thank you, sir.
So, good morning, friends. First of all, good morning to Dr. Thomas, Director, St. Gates Group of Institutions, Dr. Joseph, Principal, St. Gates, Dr. Jacob, HOD, and my good friend Matthew, because of whom I am here. Okay, we have been good friends for many, many years, almost 15 years, I should say, from his days from IG Karkalpakam. This particular program is a very, I would say, tribology is a very crucial topic everywhere, whether it is that we talk about in structural applications where people talk about coatings to improve the wear resistance. Quite a number of people are involved in this. A lot of industries are involved in it. I'm very, very happy that such an important topic has been chosen by your institute to dwell upon it for almost 4 sessions, 4 series, and covering almost every aspect of surface engineering and tribology. Wonderful. When I was hearing about the various topics that were covered, I was very happy. I'm not, to be honest, an expert on tribology, I would say. Not even on a surface characterization, but the word characterization is something where possibly I have contributed to a nano level. I can say that. I'm a macroscopist from my, I would say, PhD days. It's more than 30 years now. I've been doing microscopy, and we try to do microscopy at the smallest scale, go to almost up to the atomic scale. Transmission electron microscopy was the kind of bread and butter of my life all these years. And then we went into much deeper microscopy, what we call it as atom probe tomography. Most of you possibly in the mechanical engineering are aware of microscopes such as optical microscope to start with, and a scanning electron microscope to a large extent. Beyond that, and we also do a lot of surface roughness analysis, including possibly if you want to go up to the level of atomic force microscopy. Otherwise, generally we do with a lot of profilometry is what we look at, and try to understand the failure of materials using scanning electron microscopy, the so-called field of fractography. Okay, that's something which is a kind of a 3D imaging that we do in a scanning electron microscope. We can also do 3D imaging of how atoms are distributed in a material. That's something very, very beautiful. All through my life, I used to bring school children to our microscopes to show how atoms can be seen in a microscope. That's always very exciting for a young kid to see that, yes, what I read in my books, I can actually see it. And it's fantastic when you work on things like that. And that has been always exciting for me all these years, and to the extent that I don't feel like sleeping. So that is the kind of excitement that you get when you work at the bottommost level of materials and understand them and use that understanding to design new materials. All the understanding that we try to develop through all these characterization tools that we talk about are supposed to be helping you in designing new materials and designing materials. For example, we have done what is called self-cleaning glasses. We did nano coatings on glasses so that no raindrop stays there, and even, for example, if you have any unburned fuels coming out of your emissions of automobiles, if you can imagine huge buildings in cities nowadays with all glassy buildings, okay, you have some stains forming. Many of these what are called exhaust gases, when they try to deposit on these glasses, you have some kind of oily markings. Okay, can we remove them without anybody going and cleaning it on a daily basis? So we call these as self-cleaning glasses. So there are wonderful nanotechnology coatings that are available which can do that. We have developed these nano coatings with the help of what is called ARCI in Hyderabad. We have now transferred the technology and people are using it in a big way. Also, of course, the specs that I use, we have coatings which are wear resistant coatings, no scratch proof coatings that we talk about. So these are other coatings which are extremely small in size, in their thickness of the coatings when compared to typically a weld overlay or any other bulk coatings that we do, which are much thicker. For typical wear resistant in structural applications. We also did nano coatings on ladle refractories in steel plants. For example, we did it with for Vizag steel plant. We are doing it with JSW Jindal Steel, where you have huge ladles which hold molten steel at 1600 degrees centigrade, almost 500 tons. And there is a lot of wear and tear. There is a lot of erosion. Okay, can we increase the life of these bricks, refractory bricks in these ladles by a coating? We were able to demonstrate that yes, if you give a nano coating, which is having a thickness, total thickness of approximately about 10 microns, and such a coating gives you almost double the life of a refractory bricks. We also try to give coatings on gun barrels inside so that the wear resistance can be significantly improved. So things like this, you have numerous applications where one can think of. We also have, what are called metallic glass coatings, which can give you exceedingly high corrosion resistance. Recently, even Tata Steel is talking about giving such kind of coatings. When you have these rebars, which we use it in reinforcement concrete, many times when you make these rebars through whatever hot rolling process and things like that, and you try to transport it to long distances, for example, to another country in ship, by the time it reaches there, it gets rusted. So people are worried about how to control that. We can have a very thin coating of glassy coating on that so that it don't get rusted easily. Things like that can be done very easily. We are now into what are called high entropy alloys in recent times. And again, these are also wonderful materials for coating applications, particularly wear resistant applications. In all applications where you need a high hardness coating, better than even stellite. We are now found materials which are better than stellite in high entropy alloys, and also materials which can give exceedingly high oxidation resistance. For example, recently we patented a high entropy alloy which is better than nickel-based superalloy in terms of oxidation resistance. Like that, I can keep going. So many exciting possibilities exist. We have projects with GE, we have projects with even Boeing is thinking of having materials like that. So there are numerous aerospace industries which are thinking of such coatings on their turbine blades, for example, and trying to find out if we can have better coatings for not only giving you strength at room temperatures, but also high temperature strength, hardness. Okay, these are certain materials which can give you exceedingly high wear resistance, even at temperatures as high as 800 degrees centigrade. Okay, so that is the beauty of variety of such materials that are coming along, and the characterization techniques that are coming along. Just I was mentioning to you a while ago, we have set up what is called an atom probe at IIT Madras, with the support of almost like 8 different institutions. Each of them paid about 2 crores. This is the first, I would say, a consortium mode microscope that was set up in any part of the country. This costed us about 40 crores, one unit, where we are running it 24/7. I have 3 operators who come in 3 shifts and operate it. And more importantly, it is a microscope that can be operated remotely. Okay, so people send us samples, we polish the sample, put it in the microscope, and people sit at their respective institutions, IIT Bombay, IIT Kharagpur, Kanpur, Delhi, and IIT Ropar, and ARCI Hyderabad, and even BARC, Baba Atomic Research Center. All these people sit in their respective places in front of a computer and operate the machine from their computer. Okay, this is the first of its kind in the whole world. I would say there are 100 such what are called LEAPs, local electrode atom probes in the world. Out of all these, this is the first remotely operable atom probe, and that is the beauty. I mean, so that's what I keep telling to students. Many students must be sitting here. You have fantastic facilities within the country. You don't need to even think of going abroad for a PhD, provided you want to do good quality research. And that's the bottom most important. If you are into research, what is important is what is the quality of research that you do? What is the impact that you are making based on your research? And that can only happen when there is a passion, when you feel that this is my whole life, rather than it's just one job that I do every day. And I go to the extent to tell my students, you should choose a profession where you don't wait for a Saturday, Sunday. So that if you can find that to be research, and you can do wonderful things. Okay, and any researcher should have that what I would say kind of a deep commitment towards what you do. And once you have that commitment, there is excitement. It is like a romance, I can tell you. So I have been enjoying this for 30 years, and I'm sure every one of you who find this to be your part of your soul, and make it as your life partner, and you will be able to contribute significantly. That's important. When there is a commitment and a perseverance and a passion towards anything, the contributions that you make will be definitely known to the whole world, and one day you will become a role model for the rest of the world. And with that few words, thank you very much for this opportunity, and I wish the whole workshop all success to all the participants who are participating in this workshop. Do well and carry on whatever knowledge that you are gaining from this workshop, and implement it into your own research and pursue that research with a lot of passion. I'm sure you will find satisfaction at the end of the day when you pursue anything with passion. Thank you very much.
Thank you, sir, for your kind words and doing the honors. It's a privilege and honor to have you here as the inaugural speaker with us today. Thank you, sir. Thank you so much. Now, moving on, I invite Professor Dr. M.D. Matthew, Dean of Research of St. Kitts College of Engineering, to present an address. Over to you, sir. Sir, could you unmute your mic?
Okay. Am I audible now?
Yes, sir, you're audible.
Respected Sri Thomas T. John, Director, St. Kitts Group of Professional Colleges and President of this function. Dr. B.S. Murty, Director, Indian Institute of Technology, Hyderabad. Colonel B. Venkat, Director, Faculty Development Cell, AICTE, New Delhi. Engineer Punus George, Executive Chairman, St. Kitts Group of Professional Colleges. Dr. C. Joseph Kunyubal, Principal, St. Kitts College of Engineering. Dr. Jacob T. Varghese, Head Department of Mechanical Engineering. Dr. Jason Chirianesek and Dr. Chapo Panokoshi, Professors in the Department of Mechanical Engineering and STTP coordinators. Faculty members, research scholars, and other participants. When I think of tribology, I am reminded of corrosion. Corrosion is a very important chemical and metallurgical phenomenon. It's a surface phenomenon. And corrosion of a material is governed by the environment which is surrounding the material. Likewise, tribology is predominantly a surface phenomenon. Friction and wear, which are the two major manifestations of tribology, are also governed by the fluid or the medium surrounding the material and the component. So controlling corrosion as well as friction and wear have huge economic benefits. This STTP in its 4 series has considered every aspect of tribology. A huge wealth of information is being disseminated. I have no doubt that the participants have benefited very much. They must now think of pursuing active research. And I would like to re-emphasize the exhortation by Dr. B.S. Murty about research. That's a profession where you don't wait for the holiday, Saturday and Sunday. So I request that they must now think of pursuing active research on one or more problems in tribology based on these presentations and discussions. And I would also say that let the coordinators consider forming a task force to focus on tribology related research using this STTP series as a springboard. I wish all the participants very fruitful deliberations over the course of the next 6 days. Thank you very much.
Thank you, sir, for your kind words. Now, we are moving on to the end of this inaugural session. Now it's time to wind up this inaugural session. So I call forward Professor Dr. Jason Cherry and IICTE, who is the coordinator of this STTP, to deliver the vote of thanks.
Yeah, good morning, everyone. As we are coming to the close of the inaugural session of the part 4 of this STTP series on tribology and surface engineering. I actually recall, it's been a marathon series, and what we had envisaged is actually a 1-week series, and now the pandemic has actually provided us an opportunity where we could increase the number of sessions fourfold by having it in 4 different weeks. And also we had the pleasure of listening to or hearing from a lot of experts and resource persons in this particular area. So now I'll come to my duty of expressing our gratitude. And it's a great pleasure to express our thanks to our director, Sri Thomas T. John, for the presidential address. And we would like to express our thanks to Professor B.S. Murty, who's the director of IIT Hyderbad, for the inaugural address. And sir, I remember you broaching the subject of, quoting on your classes. And I do recall this because especially with all the online classes now, I can see myself, on the screen, and I can see this blue tint on my classes. And I do remember going to when I went to get my classes done, they were offering me all these different coatings, which range from a small amount of money to all the way up to like 35,000 rupees or so. And so I told them, you stop, because they just kept hiking up the price and said that, you can have better coatings and it's going to cost you so much. And I said, okay, when it reached 10,000 or 9,000, I said, okay, now this is the time to draw the line. So the thing is, the cost involved as we keep doing research in this area, and when we do advances in the materials and also in the processes which are involved in, depositing these materials, then you can actually save a lot of money. So there's also a cost reduction which comes with active research and coming up with different processes that we go through. So thank you, sir, for your words and your encouragement. And I would also like to express a special thanks to Colonel B. Venkat, who is the director of the Faculty Development Cell of AICTE, for his immense support from the outset of this STTP program. And I'd like to thank our principal, Professor Joseph Kunyapol, for his encouraging words, and our Dean of Research, Dr. M.D. Matthew, for his enthusiasm. A hearty thanks to our head of the department, Dr. Jacob T. Verghese, and my co-coordinator, Dr. Chako Pranav Koshi, and the team from mechanical engineering who have been volunteering their help during this program. And special thanks to all the subject experts who have given their consent for to enlighten us over these 6 days, and all the participants who have registered for the STTP program. I hope that all of you will be greatly benefited by this series on surface characterization and treatments in tribology. So have fun. Thank you.
I think we should thank our Master of Ceremony, Greshma.
Thank you so much, sir. Thank you so much.
Thank you, Dr. Murty.
Thank you, sir. Thank you very much. Wonderful meeting all of you. Thank you.
Thank you, sir.
Thank you, Dr. Murty, for agreeing to inaugurate at short notice.
Ready. Always ready. Thank you.
It's a pleasure seeing you after a long time.
Thank you. Thank you, friends. All the best to all of you.
Thank you, sir.
Sometime soon.
Thanks a lot, sir. So here we are officially ending the inaugural session by our national anthem.
गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you.
Thank you all for your cooperation with us. And now we are officially ended our inauguration. Now we have Dr. Jitendra Kumar Kartiar, who will be handling the first session of the day on the topic importance of surface characterization and surface engineering methods in tribology. Dr. Jitendra Kumar Kartiar is a research assistant professor in the Department of Mechanical Engineering of SRM Institute of Science and Technology of Tamil Nadu. Professor Dr. Jitendra Kumar has been with us throughout from the past 3 sessions. So to give a briefing about our speaker, I would like to hand over the platform to our coordinator, Chako sir. Over to you, sir.
Thank you, Grishma. So today in the morning we had a inauguration schedule, wonderful inauguration schedule with Professor Dr. B.S. Murty, who is presently working as the Director of Indian Institute of Technology, Hyderabad. And he has given us a wonderful insight on the importance of this materials advancement and its characterization. Especially he has told the facility that he has brought to our country, which is the world-class Prof tomography facility, which is available in IIT Madras. Actually, he is the professor of Indian Institute of Technology Madras, and now on deputation he is serving as the director of IIT Hyderabad, and he is bringing a lot of laurels to IIT Hyderabad with his multi-talented as well as significant research contributions to the field of materials. So we are now moving on to the first session of our 6-day short-term training program sponsored by All India Council for Technical Education, New Delhi, on the specific topic surface characterization and treatments in tribology. We had previously 3 sessions, 3 series which were particularly talking about tribology, and the 4th one I have dedicated it to particularly for surface engineering and surface treatments. So it is my pleasure to invite our first speaker of this STTP series, Professor Dr. Jitendra Kumar Kartiar, who is presently working as a research assistant professor in the Department of Mechanical Engineering, SRM Institute of Technology, Chennai. His research interest includes tribology of carbon materials, polymer composites, self-lubricating polymers, lubrication tribology, modern manufacturing techniques and coatings for advanced technologies. He obtained his bachelor degree from UPTU Lucknow with honors in 2007. He obtained his master's from Indian Institute of Technology, Kanpur in 2010 and PhD from the same institution in 2017. He is the life member of Tribology Society of India, Malaysian Society of Tribology, Institution of Engineers, and Indian Society for Technical Education. He has authored, co-authored, published more than 60 plus articles in journals as well as international and national conferences. 2 books published such as Automotive Tribology and Tribology in Materials and Application in Springer and Engineering Thermodynamics for UG level in Khanna publications. Further, 6 books in a row to come in CRC Press and Springer Nature. He is the guest editor of 5 journals such as Tribology, Material Surfaces and Interface, Lubrication Science, Journal of Engineering Tribology Part J, Industrial Lubrication and Tribology, Arabian Journal for Science and Engineering. He is also an active reviewer of various reputed journals such as Tribology International, Wear, Polymers, Defense Technology, Colloids and Interface Communications, Journal of Material Research and Technology, Material Research Express, Applied Sciences, Engineering Research Express, International Journal of Surface Science and Engineering, Friction, Journal of Engineering Tribology, Silicon, and many more. He has also acted as a guest editor for special issue in Tribology, Material Surfaces and Interfaces, Lubrication Science, Journal of Engineering Tribology Part J, Arabian Journal for Science and Engineering, Industrial Lubrication and Tribology. He has also delivered more than 25 invited talks on various research fields related to tribology, composite materials, surface engineering, and machining. He has received the research grant from various government organizations such as MHRD, SERB, etc. He has organized 5+ FDPs by short-term courses in tribology and an international tribology research symposium recently. It is an extreme honor and privilege that you have accepted our invitation to deliver a session on the topic Importance of Surface Characterization and Surface Engineering Methods in Tribology. The session is over to you, sir, for the next 2 hours.
Thank you, Dr. Chako, sir. It is a nice introduction. And just I am sharing my screen. Yes, sir, it is visible?
Yes, yes, sir. You can make it full screen, sir. Yes, yes.
So thank you once again to invite me for this series 4 in your 6 days AICTE sponsors STTP related to the theme of surface characterization and surface engineering. I also would like to thank Director Sangates, Dean Sangates, and Head of Departments of your Mechanical Engineering Sangates Group of Institution, and I also thanks to my friend Dr. Chako, who invites me in this series so that I can deliver and share my thoughts and view what is the importance of surface characterization and how we can perform the surface characterization according to our research. So it is not important you just perform all types of the surface characterization, but according to the area, we just perform the surface characterization. Either you are working in a lubricant or you are working in a surface coating and some other area, whatever the area you are working, what type of the characterization is necessary to give you a very good publication. That is our end goal as academician. So in this, what is the basic principle behind that particular process? And then we'll move to that particular surface engineering methods. What are the methods we adopted nowadays to increase that particular wear resistance property and reduce the coefficient of friction of different tools and components. So that all the basic introduction I will give you. I will also touch little bit research part, because hope you further next 5 days everybody talk about some research, and I thought that they will little bit talk about the basics of the surface characterization. They will perform the surface characterization in every research, but why we do this characterization only, that I will tell you in further next 2 hours. So this lecture I have designed in such a way that you will get the basic insights, and also I will give you some research aspects. So these are the content of today's topic for next 2 hours. I will first section I will just delivered the basics of these surface characterization techniques and their importance in our tribology, and then we will just move to the surface engineering methods, start from the history, and then what are the different types of the surface engineering methods we are nowadays using in the field of tribology and their application, and at last we will move to the summary part. So first, you have seen that the SEM is the nothing but it is used to used for the surface topography purpose, and it is known as the scanning electron microscopy. So the basic thing in that particular scanning electron microscopy is you just your high voltage electron beam fall over the surface, and then over the surface, when high energy electron beam fall, then they can generate the secondary electron, and as well as back scattered and X-ray, auger. So if this is the electron beam, if fall over the surface, then you can see this type of the envelope it is formed in that particular surface. And in this particular subsurface, auger electron is emitted, X-rays is also emitted, secondary electron from the surface is also emitted. This secondary electron which generated, these secondary electron or back scattered electron is very important in scanning electron microscopy. In auger electron microscopy, we just focus on auger electron. In X-ray, we just focus on X-ray. So in one material, when you fall the high intensity electron beam, then the different every kinds of the electrons is generated, but what kinds of the electrons you need, that you just take care, and other whatever the other electrons is generated, auger electron, X-ray and other things, you can suppress it by the suppressor. So the basic principle is that the high intensity beam fall over the surface, that is a tungsten filament, we just use it, and these are the construction purpose of this scanning electron microscopy, and this is the image of that particular scanning electron microscopy, how we perform. This is the vacuum chamber. Inside that particular, you have you hold your X-ray sample to check the particular surface. And here, this is the electron beam, and this electron beam having a tungsten filament, and that high energy electrons beam, that is approximately 20 kilovolt. So that is, I have mentioned here, 20 kilovolt electron voltage electron beam fall over the sample surface, and then due to that particular fall, we just different kinds of the electron generated. So mostly in scanning electron microscopy, secondary electrons are very important. So you have seen that particular two types of the SEM images. SEM are used nowadays. This thermoionic guns or field emissions. So field emissions gives you the better surface topography rather than the thermoionic. Why? Because in thermoionic system, this is previously it was used in this your high energy of that electron is not that much high, so that your scattering of the secondary electron is not that prominent. So it cannot capture perfectly by the detector. So that's why the field emission electrons are used, and this creates the electric field, which is a strong electric field, and so that your secondary electron generated, and you will get a better surface topography. That's why this field emission, everybody asking about the field emission scanning electron microscopy images. And now also nowadays a chart, this high resolution scanning electron microscopy is also come into the picture. So as you increase that particular intensity of the electron beam, then your cost will also increase. So this is the close view of your specimen chamber, where you can hold your specimen, and these are the several, this is from this top, the high intensity electron beam falls over the sample, and these are the detectors. So this is called a secondary electron detectors, which can detect that particular secondary electron and capture the surface, whatever the emitted over the electrons emitted over the surface. So this detector plays a very important role, and this is developed by the Everhard Thornley, and that's why it is known as the Everhard Thornley detector, and which can consider that secondary electron only, and other electron like backscattered, X-ray and auger, all are suppressed by some other suppressor. So these are the segment you can see here. This is the EDS detector. This also you can generate that particular very high intensity electron, and then you can perform the elemental analysis and this backscattered electron capture secondary electron detector. So these detector is very, very important when you capture any surface topography. So application of this scanning electron microscopy in every field, like either from the life sciences, biology, gemology, medical, forensic science, metallurgy, even though in mechanical engineering also this application of the scanning electron microscopy is more. So this, I have taken the few sample surfaces of SU8 and its composite coating over the surface glass, and this is the bulk coating which I fabricated to develop some MEMS devices. This is the work which is carried out by my PhD student. Recently submitted his thesis, and this work published in the Friction Journal. So here you can see that this surface coating I have, this is the substrate and this is the thickness of the coating through which I can measure the thickness, what is the thickness of the surface coating. And also we can observe that the particular, if I have added some liquid fillers inside that particular matrix, then either that is dispersed in that throughout the coating or not. So that also we can analyze by this SEM micrograph. And this surface coating also, you can see that throughout the surfaces, when we added the liquid lubricant inside the solid matrix, that SU8 plus HBN matrix hexagonal boron nitrate, then also we can observe that this perfectly dispersed liquid throughout the surface. So due to which it can gives you the lower friction coefficient and high wear resistance property of this coating. So this is the application of this scanning electron microscopy. Further, this scanning, after this scanning electron microscopy, we can also do some analysis by the AFM. So AFM is also another important tool that is called atomic force microscope. So through AFM, you can observe the surface roughness of that particular nano coating or even the micro coating also. And through AFM, you can also generate the 2D surface roughness, then you can intensity of the particle, and then further you can also calculate the frictional force, this nanotravometer, Tribology also through the atomic force microscopy. You can check the friction between sol gel in the Tribology or self-assembled monolayer coefficient of friction by this atomic force microscopy. So the tip of that particular silicon nitride, and you can also modify the tip by some other means. You can say fireballs also, you can glue it, and then that tip of this atomic force microscopy is not more than 25 micron curvature. So this is another scanning probe microscope, and it develops by the atomic force microscopy is developed by the Tabor, by the simple means of that particular contact mode. So this atomic force microscopy gives you that several aspects like surface aspects, for the surface roughness. You can also calculate the friction between the atoms. You can draw the FD for friction force with displacement of your tip. So this is the very, very important tool in case of your atomic analysis or atomic force, atomic friction between this. And also you can widely used tool in Tribology. So this basically consists of cantilever, and that cantilever consists of a very sharp tip. And that tip curvature is approximately that is more or less 25 micron, and this tip is generally made by the silicon. So the silicon is very widely used material. So when I was in my doctorate, then I tried to at least replace the silicon tip and then fabricate some SU8 tip, because that is a fabrication is very easy, it is easily curable. And basically this tip, when it works on the according to the Hooke's law, and then you can calculate the sample surfaces and force between the tip and the sample by the deflection of the cantilever. So what is the deflection between the cantilever in that particular due to that movement of the surface that we calculate by the Hooke's law. So this is the kind of the AFM tip which is used, and this is fabricated over this silicon wafer. So the working principle in this, nothing but we have a laser beam, and that we have the mirror, and that mirrors reflect back, and it falls over the surface of the tip. And due to the movement of the tip, this laser beam, whatever this falls, it can detected by this force action of photodiode. So what is the movement of this laser beam here? It can move from in this quadrant. Either this is positive, negative, like that. These are the 4 quadrant. According to that, it can give you the scanning image of that particular nano surface, even though micro surface also you can get it. So basic difficulties in that particular one atomic force microscopy is setting of this laser. So if you set perfectly this laser, and if your laser pointed out in this neutral axis, means is 0 position, then only your AFM will work, otherwise it will not work. So initially, at least your laser, whatever fall in this photodiode, it should be in this center zone. So if it is not center, you just set it, because in my PhD, I handle 3 equipment. One is this atomic force microscopy, and another one is I handle this scanning electron microscope and 3D optical profilometer. These 3 instruments I personally handle, and I just perform some generate some micrograph to other students from other department, either biological department, who wants to some analysis of their surface. Or for this one girl I know, she fabricated some soil gel technology, and the foam she fabricated, and I just capture those images by this atomic force microscopy. So this is the basic feedback signal, like when it is moved over that particular surface or raster scan. According to that, your cantilever tip move over the surface. So there are 3 modes we just use in that atomic force microscopy. So if your surface roughness of that particular sample is very good, then you go for the contact mode. If your surface roughness is little bit, at least in 1 micron or 2 micron, then don't go for the contact mode, otherwise your tip will break. So when you choose that particular selection, which mode you want to go, either contact mode, non-contact mode, or tapping mode. These are the 3 mode, and selection of that particular tip is also different. So all 3 modes having the different types of the tip, and one tip cost is the $50. That time in 2016 I'm talking about. Nowadays I don't know what is the cost of that particular one tip. So nobody ready to give you that particular easily slot, because if that tip is only, you can scan it in contact with mode 1 or 2 times only. So when your tip is moving, so this force displacement curve is form, and this when it is moving, this deflection happen, and due to that particular adhesive forces between that particular tip and the sample surfaces, the weak van der Rohe forces, when it can detach from the surface, so it can, that's why this bottom one, it can come as attractive zone, and then again it can move high forces, and because of that reason it is again goes to the 0. So initially your repulsive forces is there, then but after some time it is attractive forces because of the high force applied over this tip and sample. The atomic bonds, whatever it is there, the weak and this van der Waals forces, atomic forces attract this tip, and it can adhere over the surface. Because of that, this zone will form in that particular contact mode. But in non-contact mode, this zone will not form. It directly goes to that particular surface. So this is the difference between the contact and non-contact mode. So this is the foam safe structure which this generated at that time, and they just make these hexagonal structure for foam. So they just soul gel type technology. This in biological sciences. That girl was that time doing PhD from the biological science. So they just generate some foam-based structure for vibration shock and other things, and that structure I have taken by the contact mode. And this 3D structure you can get it, or even though you 2D structure you can get it. For my own sample, I have tested this SU8 and hexagonal boron nitride composite with liquid filler, and this gives me the insight that whatever the coating I have generated, that have a nanotextures, because these nanotextures also play a very important role in a wettability, increase the hydrophobicity, and some other terms, because area contact is reduced, due to which what happen, your frictional forces is also reduced. So this is the these types of the images helps me in explanation of the why the reduction in the coefficient of friction is happen, and what is the basic phenomena in reduction of the friction and increment of the wear resistance. And also this can also help me in explaining of the wettability test, because this surface gives me the more hydrophobic in nature, that approximately 100-degree water contact angle. So why I achieve this 100-degree water contact angle? So these surfaces, due to this surface, I can observe that this nanotexture is present, and due to the structuring, it behaves, the contact area is reduced, and it can increase the surface property, hydrophobicity of that particular surface. So this is the pure SU8, and after adding the hexagonal boron nitride filler, solid filler, this looks like the surface. Then adding the liquid filler, then whatever the bigger pores, it can fill perfectly, and it gives a very smooth nanotextures over the surface. Now another kinds of that particular surface characterization which is used, that is called FTIR. So this FTIR is basically used to analyze that particular elemental bonding between whatever the new bond formation in your sample, or what type of the bond formation after mixing the 5 to 6 compound. Like in powder metallurgy, if you want to make that particular break composite material, then there we just mix the 3 to 4 powders, and after mixing that, sintering, blending, and whatever the other processes you perform in powder metallurgy, then finally some new bond will come out. So that we will check by this Fourier transformation transfer in infrared spectrometer. And in this particular infrared, we are just use the infrared, X-ray infrared, to generate that particular graph. In that, what is that particular region from that 0.8 micron to 2.5 micron is called a near infrared. And if you select this region, then it's called the medium infrared, ordinary infrared, that form. If you're called far infrared, that is a distance between 50 micron to 200 micron. So according to that, you can also calculate the functionalized group, either any functionalized group is present in your compound or not. That also you can analyze by this using FTIR method. So according to our research, we just choose this FTIR method. So it is basically methods to measuring all the infrared frequencies. So your all infrared frequencies fall over the surface, whatever the surface you want to measure. Either you want to measure the powder also, you just powder you just make in a slide form, and that slides, you just follow the infrared, and that infrared checks all the frequencies rather than individually at dispersing instruments. So all the frequencies at a time, they can capture it and then they just give you. So basically this AICTE-IR spectroscopy, it works on the principle of Michelson-Morley experiment. I hope you have already know about this Michelson-Morley experiment in the physics, and this is a very good initial setup in that particular physics, and after that Newton fringes and other comes into the picture. So this is the basic setup of Michelson-Morley experiment which we use in that particular one. So here this is the fixed mirror, this is the movable mirror, and this is the infrared sources, this beam splitter. And according to this movable mirror, we just here fall over the sample surface, and then electrons are generated, and those back scattered electron can detect by this detector and gives you that particular graph, whatever we want to generate it. So this is the basic procedure in that particular AICTE-IR method. So helium neon laser we just use as a generate for the laser, this infrared in that particular one. So interferometer also, it plays a very important role in that particular one. So application of this AICTE-IR is either you want to identify the organic compound, structure determination, then chemical reaction. Then also if you want to analyze the complex molecules, in that what are the molecules present in your substrate, because sometimes some question asked, you have written some statement that in this particular coating they generated the very smooth surfaces, and why this adhesive nature shown by this compound, because so this AICTE-IR analysis gives you that better picture if any further new compound or formation over the surface or not. Then it is very good in explanation also, whatever you are telling. So this AICTE-IR I just perform on the 3 carbon material, and this is this paper was my first paper in PhD, and that published in Tribology Material Surface Interface. So in this paper, I have chosen 3 carbon material, and I just want to analyze that which is the best carbon material amongst all, graphene, graphite, and MWCNT, which gives you the lowest friction coefficient, and why. So in this, I have tested that particular graphene, graphite, and MWCNT. And according to this wavelength, whatever the frequencies we have tested and percentage transmission, we observed that particular wavelength here in graphite. We found that this hydroxyl group is very, and this hydroxyl peak is very wider and big in the case of graphite, and graphene, and it is very less, and in MWCNT it still is present. So that's because of that presence of this hydroxyl group, the graphite is always shows the very less friction coefficient rather than other carbon material. That other carbon material is also good, but that depends on the application. So in case of coating, we just performed either diamond-like carbon coating or graphite. So diamond-like carbon coating is also a special types of the graphitic coating. So that is presence of the OH group. This OH group, that is a functionalized one, and it can react over the surface, and it can that because of that reason it gives the lowest coefficient of friction. So this is this AICTE-IR analysis I explain in this way why this friction reduce in that particular all I just mix all these 3 types of the filler in the SU8 material. So further we move to the another type of the Raman spectroscopy, because in AICTE-IR what we will do in that particular one AICTE-IR, we are infrareds are falling over the surface. So what happened, these infrareds by absorbed by these atoms. So that due to the absorption of atoms, sometimes what happen if your coating or something is not that much you don't know about more about that particular coating that is unknown. So don't go for FTIR, because that will not, sometimes it will not give you that particular correct result. Because of that reason, because infrared, whatever it is there, that absorbs by the atom, and sometimes it will not give you the correct reason. So that's why this Raman spectroscopy came into the picture. And C.V. Raman discovered this Raman spectroscopy, and here also we use that particular infrared sensors, but these infrared is not absorbed by the atoms present in that particular substrate. It is only creates the vibration, and due to that particular vibration in that particular atom, it can change the peaks and shift in that particular peak. So it gives you the very good results in case of if you want to study about the new bond formation in your compound, or some other analysis you want to perform related to either C double bond C, or what type of the bond sp2, sp3. These are the bond analysis we can generate by the Raman. That gives you the more accurate result. But FTIR you will find easily. So FTIR is also acceptable in the paper, but if you can present the Raman, so nobody can question whatever you have mentioned in that particular one, because it can generate the vibration in between the atoms, and the difference in the wavelength in the between the incident and scattered visual radiation correspond to the wavelength in the mid IR region. So this is the basic difference between FTIR and Raman spectroscopy. In FTIR, your infrared absorbed by the atom, but Raman, your whatever the light fall, that creates the vibration over the surface. So basic principle here, when monochromatic radiations incident over the surface, and then light falls and interact and some fusion happens, and this electron is scattered, and due to that particular coherent sources, that is basically laser sources, then these can move from the lower level to the higher level or excited level, and it can gives you that particular bond formation in that analysis. So these are the particular three types of the radiations which can generated in that Raman spectroscopy: stroke scattering, anti-stroke scattering, and Rayleigh scattering. So this, I hope you have already studied in that particular chemistry part or physics part, when your electron, whatever the energy of electron, it can move due to that particular energy, it can go for higher level, and after that higher level it can again move to the lower level, and this difference between this energy level between these two, and this is called a Raman effect, and that gives you that particular spectra of your wavelength, this energy difference between these two rays gives you that particular bond strength or compositional analysis. So these are the two basic things which is widely used in that particular Raman spectroscopy. So this is the basic instrument. So here your sample, you just fall the laser over the sample, then different wavelength generated by the sample, and due to that particular wavelength, it can gives you the wavelength sector. So, and this can give you that particular, sorry to interrupt, one call is coming, just so so application of this Raman spectroscopy is basically in the analysis of the structure, new bond formation, composition, stability of the coordination compound, and it can basically range in that particular 100 to 700 centimeter per centimeter. So what is the area, what is the length you have this how much length your infrared falls over the surface, according to that. That's why this range of that particular one in the per centimeter. So vibration are frequently in Raman, so that we just calculate, and this here, due to that particular vibration, there are two types of the band is formed. that band analysis is very, very important in your whatever the object. So G band or D band. So these G band and D band gives you the ratio of sp3 to sp2 by structure. So if D band is generated by the in vibration in that particular generation of inline vibration, and this G band is generated in that Raman is because of the outline vibration of that particular infrared. So this peaks intensity of or height, it depend on that particular availability of the sp2 or sp3 structure inside your compound. And sometimes what happen, this is the primary compound you have generated by the Raman, but after some time new formation after test, tribological test, maybe these peaks can be shifted. So this shift of the peak also gives you the better result. Means why this shift of the peaks is generated, because of that shift you will get the less coefficient of friction or high wear resistance, or higher wear or higher coefficient of friction. So these peak analysis is very important. So sp2 sp3 structure we can get it by this Raman intensity and versus the wave number. So next we just move to that particular thermogravimetric analysis. So in this we just check the thermal stability of any compound whatever we have even though if we can develop some new coatings. So what is the thermal stability of those coatings? That is very important in any paper, and they can widely ask. And because if you want to use those coatings in the turbine, and turbine is running approximately 1000 degrees centigrade, then this TGA play a very important role. If your coating is not sustained up to more than 1000 degrees centigrade, then those coatings is useless coating. So but those are also can be used but lower than 1000 degrees centigrade. So but for particular application, so when you decide any types of the area where you want to work, then thermal stability of that particular composite or coating or compound, it is very important. So here what happen, your temperature, with respect to temperature, you can obtain the weight loss. So this weight loss according to the temperature, this gives you the thermograph. And due to this particular TGA also, you can quote the things like this reaction happen is exothermic or endothermic reaction. So either heat is generated or heat is evolved. So that is also very important statement in any tribological analysis. So this is the instrument where you just kept your sample, whatever the sample you want to test it, and that is go inside that crucible. You just pour your sample, and that crucible is connected with the balance. And if balance is there, like if you want to only pour 1 milligram, it's 11 o'clock. And then if it is not 1 milligram, then the feedback system is provided. And again, you just check it and pour 1 milligram that particular compound. So this work I have tested my samples by the TGA, because SU8 that is a polymer, and polymer the temperature degradation is very, very less. So when we add that particular lubricant, that is like when we add that filler, either solid filler or liquid filler in the SU8, then what is the improvement in the thermal stability? So here you can see either the degradation in the two terms. So up to 100 degrees centigrade, any coating can be evaporated, the water molecules, whatever the moisture present in that particular one. So after that, you can see this further decrease in that particular one. So this is because another epoxy element, this is the one-time decrement in that particular one. So this is one decrement, first decrement, and another second decrement happen in this. So this is the basic temperature where decrement is started, and this is the temperature where your decrement means you can stabilize your particular sample. So this temperature is very, very important for analysis. So what we observe that in that particular case of the SU8, after adding that filler, we can increase this particular temperature little bit, 120 degrees centigrade, the difference between this. So that analysis is very important. Either after adding the filler, your polymer behavior is changed or not, or your thermal stability of the change or not, because sometimes at the interface, always the high temperature rather than the outer surface. So wherever two bodies are meeting each other, due to that frictional heating, that generates the instability also sometimes in your coating. So if your coating is whatever you have developed is not that much temperature sustainable, then your coating is not suitable for that particular purpose. So that is the basic thing in that particular TGA analysis which we perform. And we just conclude that after adding the filler, even though liquid filler also, our temperature is increased at least 100 degrees centigrade from the pure SU8, that is also called a polymer, epoxy polymer. So application is that particular determine that purity and thermal stability for both primary and secondary. So here one more thing also, this is called a primary decrement and secondary decrement. So whatever, how many decrement is there in that particular graph. So why these decrements happen in that graph. So in this graph, like in red color, you only see one decrement. After this only decrement start. But in this bluish color, you can see here, after this 100 degrees centigrade, up to 100 degrees centigrade, you can write down up to 100 degrees centigrade, whatever the moisture present in that, that is only evaporated. So that loss in that particular material due to the moisture. But after that 100 degrees centigrade, why the degrade in that particular mass loss or weight loss, that is very important. So in bluish color, it is also shows a this primary decrement and this is a secondary decrement. So why this start approximately at 160 or 180? So in bluish color, because the liquid droplet is there. So we add the perfluoropolyether in SU8. So this decrement is because of the liquid one. So liquid molecules are there, and these liquid molecules evaporated at that range. So 150 to approximately what is the temperature, 240 or 250 like this. So up till this temperature, your whatever the PFP molecules that totally evaporated, and the loss in that sample because of this one. And then after one, and again another loss is started here. So that loss is because of all the things is means your material, whatever you have pour inside the crucible, that is also finished, and after some time residue is formation. So this decrement is there, and after some residue is formed at the end, and because of that one, this line is because of that residue present inside the crucibles. So but our main focus on this, when our material shows the degradation, so that is the key critical temperature point or thermal stability of that particular material. So that type of the observation also you can see in your samples, either this, why this decrement happen, why this decrement happen, why not in others. So this is very, very important. So it is used to study the catalyst, the change in the chemical state of the, maybe also study the TGA analysis. So this TGA is basically tells you about that particular thermal stability of your component, and also it can gives you that particular what type of the reaction happened if it can work at the high temperature or whatever the temperature. So either exothermic reaction or endothermic reaction. So this can also tell you. And this is the another surface topographic thing. So this profilometer, and this I also worked in the IIT Kanpur, and I was the one expert user in that particular area. So this basically profilometer works on the principle of Newton fringes. So this interference occurs because of the light source fall over the surface, and these interference gives you that particular bright fringes and dark fringes. So this bright and dark fringes, the part difference between these bright and dark fringes gives you the surface topography. So first fringes form on the surface, and then fringes form on the depth. So that is the analysis. If you have some cavity over the surface, then first on the top surface your fringes will form, and your bottom surface fringes will form at last. In that way also you can analyze the step height by this profilometer. So this is the basic principle of this profilometer, and these are the difference between these interference between bright and dark fringes gives you that particular surface topography, surface roughness, and also step height. So this profilometer is basically used to give you the three-dimensional structure and surface roughness, all types of the surface roughness, RA, RZ, RSQ, RT, and you can also calculate the step height in that particular, what is the coating thickness in somewhat extent, but the same image gives you the better picture of this coating surface. In coating, what you will do, if you have performed coating analysis, then you just erode some coating material from the substrate, then it can generally make this type of the step. So what is this step height? That you can calculate by this 3D optical profilometer, and also more or less it can give you the average thickness of your coating. So this 3D optical profilometer works on the two types of the mode. One is worked on the phase shift mode and vertical scanning BSI mode. So BSI mode is generally used for if your surface roughness is in micron and you can observe to your naked eye like surface roughness is somewhat is more. So you can use that particular BSI mode. But when you can observe that very smooth surface roughness, then PSI mode is used, and this PSI mode gives you the more accurate results in the BSI mode. So this is the only difference between these two modes. So these are the few examples like how it can move in the steps. So first top surface, it can fringes will form, and then these fringes moves from the top surface. After moving these top surfaces, it can move over the bottom surfaces. So in that way you can get your step height. In spherical surfaces, like if you want to check that particular wear wall after 4-wall test, then you can see that the fringes form in the spherical nature. So in that way also, if there is the distortion in that your ball, these fringes, that means some cavity or some wear happened over the wall surface, whatever wearing wall surface. And if some structure you want to get it, so these engraved structures, so tops first it can form on the top surface and then depth. So in this way we just get the 3D image of by using that particular 3D optical profilometer. So this work I have done it, and this is the wearing wall surface. And because of that reason, I just check it after I use the 2.5% hexagonal boronite in coconut oil and I perform the 4-wall test strip. And we just observe the surface roughness and we just get it the very smooth surface. You can see in 3D image the smooth wear scar in that particular by adding this concentration. And in this way also we can check the 2D graph, and this 2D graph also gives me the what is the depth of wear scar which is generated. So this is our level, and what is the depth of the wear scar which is generated. So what is the depth in between here? So that also you can calculate it by this one. And this RA value is very, very important for roughness, and other values is there, but mostly we just show in any paper that RA value. So that is the this 3D optical profilometer. Now we move to the XPS. So in scanning electron microscopy, we also perform the elemental analysis, but that elemental analysis is not accurate, that much accurate, because what happens is sometimes oxygen is the one element always comes in the when you perform EDS analysis by the SEM. So we just remove manually which are unwanted element for your sample, and you know better what is the composition in your sample. Then only you can select the element manually in that particular EDS analysis. So that also acceptable, but that is not that much acceptable. If you can show the XPS data, then nobody question you either that element is present or not, because XPS gives you that particular very accurate data, even though so XPS is performed rather than the EDS analysis. So these both are used for the elemental analysis. So how much percentage of your which element present in your thing. So XPS is used even though which element you don't know any composition. So for unknown composition, unknown material, you can find out the elemental analysis, then you go for the XPS. That gives you the correct result. Because in EDS, we always select the element. If you know the element, then only you can select it manually, and then it gives you the some percentage, weight percentage or molecular percentage, whatever. But if you don't know any composition in your compound, you get some material and you want to know what are the composition in this material, then go for the XPS. So in this XPS analysis, it is used for the final find the chemical composition, chemical state. Also, you can also use for the electronic configuration of the material, and it is generally worked on the photoelectric effect. So which photoelectric effect present in the 1905. So it is very simple and widely used techniques to obtain the data, and it can also very easy to analyze. What is the meaning in this? We just X-ray light is fall over the material, and it is the variation in the different wavelengths. So 0 to 1300 angstrom or 1400 angstrom. So each material is having its own wavelength. So according to the wavelength, you will get the peak in your graph. So in that particular wavelength, what is the intensity of the peak? That gives you the percentage concentration of that element. If there is no peak in that particular wavelength, then that is not no element. So it gives you that particular wavelength according to the each element wavelength, and in this way you can calculate the concentration. So X-ray is falling, and then due to the high energy X-ray, then it can emit that particular electrons from this cell, and that it can generate the phonon. That is a photoelectric effect, and this is also atoms release energy, and that is called the Auger electron. And this XPS analysis, we could just detect those Auger electrons from the surface. So that is very important in case of the XPS analysis, Auger electron. So this is the basic setup of your XPS thing, and very complicated sensors we just use here. We just apply the samples, and then electron beam and falling electron, okay, and then whatever the X-ray sources, and that Auger electron captures by this generated, and these electrons is captured by the detector. According to the wavelength, each material having the different wavelength, according to that we just capture in the peak form. So this is kind of the peak. You can generate the signals in that particular electron volt energy, and in this way you can analyze what type of the element present in that particular component. So due to the wavelength, according to the wavelength concentration, we just check that element. Iron, it is this cobalt, nickel, copper, zinc. So these are the few elements present in that particular this compound or component. So because we don't know anything, if you don't know any composition in any material, then go for the XPS. And further also, you can also check the chemical shift, what type of the bonding present in that particular one. So that bonding is also you can analyze by this XPS analysis. So these are the applications, even though in industry, failure analysis, polymer surface, corrosion, adhesion, semiconductor, dielectric material, thin film coating. this XPS is used widely, and also it can used for the measure the elemental composition, even though surface is 1 to 12 nanometer required. So surface preparation is also very important for XPS analysis, and it can gives you the chemical or electronic state of each component. So these are the analysis which can be performed by using the XPS. So next we also check the if you can perform the coating, then we just check either coating surfaces shows the hydrophobic or hydrophilic in nature. So this is the goniometer which you used here. You can, this is the manual one goniometer. Here you can move by this wheel according to this tray. And here you just keep it your sample, and from top you just drop your water molecule. That is a 2 microliter. That is the density of that particular volume of that drop fall over the surface. And this is the camera, and light fall over the surface, and this camera captures that particular angle, and it can gives you in this computer. And according to that, you just analyze the angle. So these are the few samples for my coating, SU8 coating. I have analyzed that SU8 HBN coating. In that, I just see that particular SU8 HBN with PFP gives more hydrophobic surface, and also AFM analysis shows that the nanotextures, so those nanotextures help making the surface very hydrophobic. So, and also this surface gives me the better wear resistance property and lower friction coefficient. So this wettability analysis is only required for checking the surface energy and surface hydrophobic surface and characteristic of surface nature, either that is hydrophilic or hydrophobic in nature. So these are the few surface treatment processes which I just show you. Further, there are several physical treatment, physical characterization process, then mechanical characterization process like impact test, Charpy test, ISO test, tensile test, then nano indentation test, micro indentation test. So those are the mechanical characterization tests. Then you can also perform the physical analysis, physical characterization, like if you are working in a composite, then also you can use that particular absorption test. What is the densification in that particular one? So density analysis, then viscosity analysis. So these are the few characterization comes into the physical mode. So now we move to the surface characterization, surface engineering, and the basics of the surface engineering, how many methods are used in that particular surface engineering. So approximately this surface engineering develops in 1900 with the plating of the gold film by the Thomas Edison in that particular his experiment. So after that, this surface engineering comes into the picture, and in 1983, the Vargas was the amongst first developed the plasma and ion modification equipment for coating of this coating over the surface. And this 1960 approximately 9 ion planting was developed, and this also gives you the some plasma assisted coating in that particular deposition. And early 1970 the film deposition and plasma process is generated. So this is the very brief surface engineering thing. So what is the meaning of surface engineering? Means you can modify the surface. You are not modifying the whole bulk material. You are modifying only the surface, like coconut shell. Inside that particular coconut shell, that coconut is very softer, but outside it is very hard. So you are not modifying the complete, you are modifying the surface. So the definition of the surface engineering is modification of near surface structure by changing the chemistry of the surface, property of the surface, substrate surface, and also due to that particular change, you can achieve the superior performance and durability, you increase the durability. So this surface engineering combines the chemistry, physics, and mechanical engineering with metallurgy and material science, and it contributes virtually all engineering disciplines, whatever the discipline you are, either in nanotechnology, so or whatever you are, this surface engineering plays a very important role. So you can change the material. It can be by the giving the metallurgical or mechanical, physical or chemical means. So you can produce a very thick layer to thin layer of the coating over the surface to change that particular structure. So these are the few coatings, multi-layer coatings, nitride coatings, and some other kinds of the application we just use it. So this basically it is coating is either in the form of metallic coating, non-metallic coating, polymer coating, whatever the coating you can use it to enhance the surface only. You are not ever changing any substrate. So why surface engineering is important in that particular aspects in tribology? So any component, so engineering component usually fails when its surface cannot be adequate withstand with the external forces, and these external forces may be the environmental or some other conditions, also humidity or some other temperature, pressure, so that sustain that particular external surface of any component. That is that's why the surface engineering is very important. So it improves the functionality of an existing product is only one aim of the surface engineering. That is the only thing you can improve the functionality of the surface so that your surface behaves like a super hydrophobic surface. So like Professor Murty said that he developed some coatings which is self-cleaning coating in the glass surface. So why that is also a part of surface engineering. So this surface engineering can generate the functionalized coating also, so that you can make that particular more hydrophobic or super hydrophobic surfaces over the thing, so that you your dust will not stick because it can roll over the surface. So that's why the surface engineering is very, very important. So this, due to that particular surface engineered component, gives you the high product life, improve surface resistance, satisfy the customer need, reduce the maintenance, improve the appearance also, improve the solderability, and metallize the plastic component surface also. Means you have a plastic component and over that you just coat the metal one. So that is also used nowadays. So there is a numerous applications of the surface engineering and the form of cutting tools, forming dies, decoration purpose, automotive industry, biomedical industry to make the femur head or this femur coating of the femur head with the hip and knee joint. So these are the various applications of the surface engineering where you can perform a nano coating only. Yet, even though hard disk is also whatever we are using, that is a 10 nanometer coating, and how you can improve the performance of your hard disk, that is also very important. So surface modification is nothing but it can modify the surface without changing the material chemically. So how you can modify the surface? By thermal process, by mechanical process, or other process, means chemical electro etching, laser engraving. So and mechanical process, changing the surface by texturing, using machining and blasting, and surface pinning, sword blasting, explosive hardening. So these are the various mechanical processes which are used in the automotive industry. And thermal process, like you can do the heat treatment process. So in heat treatment process, hardening is the one heat treatment process which can improve the surface by nitriding flame or carburizing flame according to what type of the material you want to harden. So this laser is used, flame is used, induction furnace is used, laser beam is used, flame is used to improve that particular apply the temperature, and then you can harden the surface. So that's why it is called a thermal process. So that surface heat treatment process in that particular material science. So this hardening is the one heat treatment process which can use to modify the surface without changing the material chemically. So surface modification is done by the changing the surface chemistry only. So these are the various thermochemical diffusion like carburizing, carbonitriding, nitriding, boronizing. So in all these processes, new element also goes to interstitial position. Like further, we just use the chromizing to improve the wear resistance, and siliconizing, and several types of the powder also you can incorporate in between one that interstitial positions of the subsurface. So electrochemical also process, chemical conservation and implementation process. These are the various processes used in the surface modification and change the surface chemistry, not change the subsurface chemistry. So what you will do, we just change the surface without changing the material chemically. Surface modification altered by the surface chemistry. Surface modification by adding new material onto the surface, either in the form of coating. So that is known as a surface engineering processes. So this evolution of the surface engineering and significance of the surface engineering is not started nowadays. It started in 1980. When we just improve the surface of the single component and multi-component, multi-layers. Then nowadays smart materials comes into the market, high entropy alloys and other things comes into the picture. So that further this surface engineering plays a very, very important role, and various methods are used. These pictures, you can see this plasma is fall over the surface and that treated over this plasma environment to improve the surface property. So another thing is material property. There are two types. Is the characterization one. In either you want to go for bulk or you want to go for surface. So if you want to go for the bulk, it gives you the strength, density, and ductility. If you want to only for surface, then hardness, friction, wear, corrosion, and oxidation. So surface engineering is basically focused on these aspects. So surface properties like how you can improve the corrosion resistance, oxidation resistance, wear resistance, erosion or abrasion, hardness and conductivity. Sometimes it is also very, very important to know the difference between corrosion and erosion. So corrosion occurs only by the chemical reaction. So if chemical environment is there, then only corrosion will happen over the surface. But erosion will happen either by the physical means or the chemical means. So that is the only difference between erosion, and that's why in electric discharge machining we just tells the because of this dielectric between tool and workpiece that erode the material and have price. So melting, evaporation, and erosion. So mostly we just call it about the erosion if there is the physical phenomena or chemical phenomena, but corrosion is very, very limited. That is only occur if there is the chemical is there, then only corrosion will happen. So corrosion will happen. Corrosion study is very important for hydro turbines or your femur head, which is used for hip joint and knee joint inside the human body. So wherever this happened in the lubricant or something, then gears, the corrosion will also play a very important role, and then erosion will also, but there we just talk about the erosion. So that is the difference between that particular one, and erosion test and corrosion test is totally based on the chemical analysis, and erosion test based on the mechanical analysis. So like in wind turbine, the erosion of the blade is occur because of the high impact of the wind fall over the turbine blades. So how you can improve the surface of the wind turbine blades, that is also very, very important. What type of the coating you can generate it so that you can improve the surface of that particular turbine blades. So nowadays also self-healing polymer composites is also developed. That is one part of your what you can say smart material. So these are the thickness, how you can select the thickness according to the different chemical techniques. So that is very important. So according to the thickness, what thickness you want. So what type of the thickness you want, according to that, you just select the particular process. So either chemical vapor deposition, physical vapor deposition, ion implantation, chemical process, thermal spray process, and welding. So these are the various coating techniques. So welding means laser cladding also, it comes laser welding and other process. So these according to what thickness you want, and according to the thickness, we just select the different processes. So surface engineering gives you that particular different gaseous state, molten, semi-molten, and solutions like sol gel method, electroplating, and molten and semi-molten laser cladding, thermal spray coating, welding. In gaseous state, we just use the physical vapor deposition, ion implantation, ion beam assisted, focused ion beam assisted, and chemical vapor deposition. So these are the gaseous states. So here we just evaporate the material, and that evaporated material coat over the surface. So these are the gaseous state, molten state, and solution state. So these are the various processes used in the surface engineering. So mechanism behind the coating, either you can diffuse the coating, or you can mechanically bond between the surface and whatever the coating is there. So different kinds of the coating, CVD, PVD, and thermal spray. So here in thermal spray, you're interlocking because of the diffusion of the material. So your high impact particles with high temperature impact particles fall over the substrate, and that interlock because of the diffusion. Because of the high temperature, it can diffuse the surface, and it can diffuse that particular surface, and they can make it. So that's why this is called a diffusion of coating. But in case of CVD and PVD, you can mechanically bond between the surface and subsurface. So this because of this mechanically bond, whatever the coating fall over the surface, best thing is if you can perform some functionalize, you can functionalize the surface by using the oxygen plasma cleaner. Then only this mechanical bonding is better, because by oxygen plasma cleaner you can generate the OH group over the surface, and then if you coat that, that's mechanically bonded strongly. Otherwise it can detach after some time. So important parameter to optimize to control the properties of substrate, coating, and interface. These are the few things. Whatever the things, like in coating, if you want to go in bulk, so what is the cohesive strength, stresses generated, adhesion, defects, or multi-layers, coating surfaces, what is the roughness, erosion rate, friction, porosity, or corrosion. Interface means in between that particular one interface, we just check it adhesion. So this adhesion we can check it the interface between these two coating by the pull-up force. So that pull-up force also we can generate it by using the atomic force microscopy. So we just apply the very heavy load over the surface, because these coating are 10 nanometer or 20 nanometer. Then it can stretch out. So at what load that your coating can be detached from the surface, that is called your pull-up force analysis by using the atomic force microscopy. And roughness, cleanliness, expansion, mismatch. So these are the various parameters according to that particular different regimes in that particular one, substrate, interface, and coating regimes. So these are the first method, which is developed in 1960 around this plasma and ion-based surface engineering technique. And here you can, large surface can be easily treated by this plasma ion and based technique. So this is this type of the technique you can easily automate it by some other means, and these by coating generated by these techniques is used for corrosion and wear resistance coating, and also you can improve the fatigue strength and biocompatibility of the surface. And by using this method, you can achieve the very achievable and controllable limit of your coating. So this is another type of this coating method, that is electron beam physical vapor deposition method, where your electron beam falls over the surface, and this horizontal manipulator is there, and this is the detector and your vertical rotary drives, and this is a vacuum chamber. Inside this you generate the vacuum chamber, and in this particular material, whatever you want to coat over the surface of this material, and this vaporize and this melted, this can come out over the surface, and you can generate the surface coating. So these type of the different nickel, chromium based, or MCR aluminum Y coating blade, you can generate the different kinds of the coating by using this method. Another type of the coating is hydrophobic coatings, which is generated either by the plasma assisted chemical vapor deposition. So you can see in coating surfaces you can generate, and these drops of the water you can see very spherical in nature. So that type of the coating also very, very important for several aspects, like self-cleaning glass. So in real estate industry, so say these self-cleaning glass, self-cleaning solar panels. So these type of the coating is very widely used in these type of the area. So you can see easily these droplets is rolls out over the surface, and these are called the different droplets which is rolls out in the surface. So that is a hydrophobic coating. Another kinds of the method which is used, the plasma etching process. So by using this method over the surface, we can improve the adhesive property of the surface. So first what we will do, we just clean and activate these surfaces by this plasma etching process. So this is like, you can say that if you want to clean your surface before coating that oxygen plasma cleaner, so what you do, you just send your samples, clean sample by after acetone in the plasma cleaner, and that plasma cleaner cleans the foreign particle by fall the plasma over the surface, and also it can generate the OH group over the surface. So that improves the adhesive property, and when you apply some coating, then it can easily adhere that particular coating if you have applied this perfect etching process. And so this is also depends on the time, and it is also a good research area in that particular nanotechnology. They are also according to that particular time duration of the means exposure, it depends on the surface quality. So that is also very important. So how much time you just expose that plasma over the surface, that is also one parameter which is necessary to optimize it. So these are another plasma nitriding process. So crankshaft and connecting rod, cam, hot extrusion dies, mold locking plates, all are plasma perform the surface hardened by this plasma nitriding one. So this is the equipment where you can have a vacuum chamber, and this is the where you can see that the plasma is generated inside that particular one, and that plasma is makes the surface harder of these different kinds of that particular material. So this is the experimental setup, and in industry how this it looks like, this plasma nitriding facility in industry. So another kinds of the improvement in thermal spray coating or plasma spray. So you have a inert gases, and that particular generate the plasma, and that plasma you can feed the powder, and that powder, because of this high kinetic energy of this powder, go substrate, and this can diffuse the surface of this material, and you can make a coating. So this you can generate by thermal spray coating at approximately 20 micron meter, and you can coat it even though alloys over the surface, ceramic over the surface, plastics and composites, so different kinds of the things you can coat it over the surface by using these methods. So main important parameter is feed stock. So how much feed stock, like in olden days atta chakki, you have seen that they just open the mouth of the, so how much amount of the wheat go inside and then crush it. So similar case, the feed stock is very important. How much particle concentration you require to send, that is very, very important. So this feed stock is more costly. It is around 20,000 USD. That's one feed stock. So these are the various types of the plasma and thermal spray. So HBOF, plasma, arc, and flame. So recently, one Srinath engineers Nagpur, they are going to install this HBOF facility in their industry. They have the laser cladding method, thermal spray coating, and other things. It is there in the Nagpur. So these are the various methods in this high HVOF means high velocity oxy-fuel. So we just use the high velocity of the oxygen fuel and to coat that particular material. So various comparison of the various thermal spray processes, which is used, and what is the temperature in between that, according to that, which type of the thermal spray process it is necessary to use in your research work. So these are the various in x-axis you can see here in column the various processes: air plasma, vacuum plasma, detonation, HVOF, flame spray, and in rows you can see the attributes. So according to the need of the temperature, we just go the different plasma spray processes over the surface. Now we move to the another kinds of the advanced coating technology like physical vapor deposition and chemical vapor deposition. So these are used for the nano coating generation. So physical vapor deposition is nothing but here you just key, this is the crucible, and this whole things you can perform in the vacuum chamber. So in that vacuum chamber, here it is having the heating filament, and you just keep, either you want to coat gold material over this substrate material. So in top you just keep your substrate material, and here you just keep it 1 milligram gold, or maybe less than that also, silver, whatever the material. That material, what happen, it can melt it, and after melting it can evaporate it. So at the time of evaporation, your substrate is top, it can accumulate those evaporated particle and the coating is generated. And then after that you just perform the this mechanical strength, mechanical characterization by using atomic force microscopy, scan, surface topography, and other factors. So this is basically used the PVD and CVD in, widely used in surface engineering to generate that particular coating of different material, even though in compound. So this PVD methods improves the hardness and wear resistance and oxidation resistance, and it is widely used in aerospace, automotive, surgical industry, dyes and mold industry, for all metal cutting industry, fire arms, optics and watches. So these type of the coating is widely used nowadays. You have seen your watches is also having a glass probe, your optics is also having a glass probe, a scratch resistance. So why these things is happen? Because of by this physical vapor deposition or chemical vapor deposition. So according to necessary actions, what type of the coating, what is the application, we just select the process. So this is the basic thing, how the plasma generated, and this evaporate the material, and we just coat over the film. And this film you can see by this scanning atomic force microscopy, and by this you can see how the atoms are homogeneously dispersed over the complete surface. So this physical vapor deposition performed in the vacuum. So this is the example. Another process is chemical vapor deposition. We just provide the chemical precursors and this exhausted and this tray and flares and resistance of the heater. In between, you just pass it gas inlet, and then according to that, we just coat the material chemically. So it is used in various form of including monocrystalline, polycrystalline, amorphous, and epitaxial coating over the surface. So it can typically in typical CVD, the wafer is exposed one or more volatile precursors. So we just use the precursor gases, and those precursor gases react over the surface, and that is called due to that particular reaction. Because of that reason, the chemically change the surface. That's why it is called a chemical vapor deposition. So what type of the precursor gases we are using, that is very, very important. So these are the various applications of PVD and CVD coating in gear industry, cutting tool industry, in hard disk, in the automotive industry, and also computer industries also for coating of the hard disk. So future direction of the CVD coating is nothing but like 1980s, and then nanotexture generated smart material, and nowadays self-cleaning or self-sustainable coatings is there, self-healing coatings is there. So that is called as smart materials. So novel coating for this architecture for 21st century is like this foam-based coating, this nano-composite coating over the surface, this textures type. This is the fingerprint, whatever we have seen that fingerprint, how this nanotextures can be presented over the surface by these type of the coating to improve this surface property, like improve the hydrophobicity in that particular. So these are the different kinds of the novel coatings for 21st century by using the PVD and CVD coating. So last part of my talk is now we move to the laser cladding, and this is this work I have used in my work. In that particular, I have make the coating over by this laser intensity by spreading the powder, and then we just like we just spread the powder, and this travels this particular that flame, laser flame, and it can melt and solidify it, and you can generate thin layer. So but the problem in this laser cladding is distortion and resolution. So this is if you can optimize the parameter, then you will not get these type of the defect over the surface. Otherwise, this distortion and dissolution is the biggest defect in the laser cladding. So in this laser cladding, you just clad surface over the thing by laser, and this powder feed is the laser. Sometimes that laser don't have the facility to powder feed. Then you can spread the powder, and then, but in that case, you will not optimize the concentration of that particular. You will not control the concentration of the powder. So this nozzle is very, very important, how you design this nozzle. So powder is spread over this nozzle, and your laser beam is also pass, and this can solidify over the surface. That is called a laser cladding. So in this laser cladding, how you can remove the distortion defect, because at that high temperature, what happens? This is the straight plate over the surface. You just solidify it. Then what happens? It can little bit distorted. So means the edge is distorted. So this is not desirable. So this can be also removed by adding the buffer layer between the coating. So this is your top surface. This is your buffer layer. Okay, this is your top surface coating. This is the buffer layer, and this is the bottom layer substrate. So if you use the buffer layer between this this coating and the substrate, then that you can optimize this, reduce this distortion effect in that particular one. Also, you can improve the bonding strength between the coating and the substrate. So that's why the buffer layer importance is very much. Recently, one paper is published in Material Science and Engineering Part B over this inconal coating. In incolon, we just perform the coating by using the buffer layer. So that is also available in my Google Scholar. If you want, if you are interested, you can go that particular paper. So this laser cladding is widely used in erosion, cavitation, and hydro turbines to improve that particular surface so that it will not wear out very fast. So these turbine blades and hydro turbine blades is also use the laser cladding or thermal display coating to protect from the environment. So this is the Srinath engineers. They have the laser cladding set up by robotic arms. So this is the laser cladding nozzles, and through which the powder will come from one pipe, and this has the sensors, and you can coat the material. So these are the small samples which we prepared in that particular industry, Srinath engineers, Nagpur. So they have the laser cladding, and recently they also wants to they are going to install HBUF facility in that industry. So this is the complete summary of my talk in the surface engineering. So either you can modify the surface by using the thermal means, or thermochemical means, or mechanical means, by short pinning, laser pinning, surface texturing, or by means of the coating. So these coatings, either thermal coatings, mechanical coatings, thermomechanical, chemical, electrochemical, or combined coating of your ion implementation. So this is the summary of my talk, and thank you very much for listening continuously. In that particular session. So over to you, Dr. Chakos.
Thank you, Jitendra Kumar Katia, for the wonderful start of our series 4. If there are any questions, participants can raise in the chat box.
Actually, I thought that I just cover the basics.
Yeah, definitely. That is required in the initial part.
Everybody is a good researcher, everyone, so they perform some characterization.
Yes.
But there are several characterization techniques which are very important in all aspects. So which is necessary in their research, that is very, very important to know, because that I face in my doctorate degree. So what type of the characterization I choose for this those composite coatings? Some told you can also perform Raman and XPS, and I thought that time this much knowledge was not there. So because of that, keeping in that mind, I just present the very brief all the surface characterization techniques, and I hope participants can choose according to their need.
Yeah, sir, one question from Professor Shiva Subramaniam. Can you suggest new chemicals for chemical treatment?
Chemical treatment for the natural fiber, that is still, I have not gone through in that much detail for this chemical fiber, but this one paper I have published, I forget the particular NOH or something, it is used to enrich that particular surface, but I don't know right now, but I will communicate to Dr. Chako, and he will share this information to you.
Definitely. If there are any questions, one more question. Can you suggest some characterization techniques and research scopes for additive manufactured components?
So in this additive manufacturing techniques, we just go for the first surface characterization is what is the adhesive strength between the two layers. So then additive, what we will do by measuring layer by layer structure. So what is the adhesion between these two layers? So this adhesive analysis is very important. Then we just go for that tribological test, friction and wear. And also you can go for the mechanical test impact strength, and also you can check the fatigue strength. Then thermal stability is one more thing. So whatever the component you want to fabricate, what is the stability of that particular one? If the where that is used, so according to that, you just select the your mechanical properties. So like fatigue strength, if there is the cyclic loading in your additive component, then go for the fatigue test. And if there is the impact absorption of the energy, then go for the impact test. So according to the application, what application you are targeting, that is very important. Like in case of lubricant, this Raman spectroscopy plays a very important role. So lubrication in the grease lubricant, what are the component fabrication of the test before the test, then only you can identify what are the changes occurs inside the grease after the tribological test. So this G and D peaks is very, very important in Raman in analysis.
Thank you. One more question from, I think they are sending.
Okay, so this biological samples, you can go for the contact mode test because those are very soft material. So always prefer the contact mode in for analyzing the biological samples. So I have tested this few biological samples in IIT Kanpur. So that's why I know. But after that, I don't know who is handling this. I purchased in that lab the PARC system, AICTE 7, and Brooker was the 3D optical profilometer, and JES is the same image, which I handled in my doctorate time. I was the expert user. So that's why I know these many things, what are the critical parameters to analyze the substrate. So how the bonding occurs in the spin coating process between the substrate and coating liquid without reaching the temperature. This you can only done by the oxygen plasma cleaner. So what you will do, you just clean the surface, and then after cleaning the surface, you just go for the oxygen plasma cleaner. So you just expose the plasma over the surface for 20 minutes, 30 minutes, or 1 hour also according to the that. And then immediately you just go for the coating by using the spin coater. So that widely used in the MEMS industry. So that plasma, what it generates the OH bond over the surface. So it can functionalize the surface first. So it can improve the surface strength or surface attraction. So that's why whatever the material you can fall over the surface, immediately it will stick it. So that's why oxygen plasma cleaner before the going to spin coating, it is very important. So what is the difference between laser engineered net shaping process and laser cladding process in additive manufacturing? Sir, this laser cladding I gone through, but I have not gone through in that particular laser engineering net shaping process. In laser cladding is nothing but your powder is coming and your laser will come, it can melt the powder and it can clad over the surface. So that laser cladding I have used, but I have not gone through this laser engineered net shaping process. I will check it and then surely I will
It's 12 o'clock.
Tell you through the Chaco sir. Then another question by Subhavarniam. How can I connect tribological field using natural fiber composite fields, sir? This natural fibers are also used in that particular so many applications, like in our aerospace applications. So when you generate the natural fiber, so mostly people prefer that abrasion test. So abrasion test is also a kind of the tribology test. So what you will do, you have generate a sample of natural fiber, and you just keep it over in this. This is the sample, and this is the wheel which rotates at a very high speed, and this can create the abrasion over the surface. So that abrasion test you can perform on natural fiber. It can gives you the wear resistance property and coefficient of friction. So mostly in composite case, we just more worry about the wear resistance property. So Abrasion test is widely used in that particular case. So there are various tribological tests: spin on disk, ball on disk, then reciprocating test, 4-wall test, abrasion test, adhesion test. So many equipment is there. So composite, you go for the abrasion test. No, it will not damage by the electron beam, but if you will not control that, chances of the damage is less. But if you not control that particular electron bolt energy of electron beam, then electron beam will damage. Your sample will not damage.
One more question that I have noticed is, sir, how to calculate the GD bar GI ratio in Raman spectroscopy?
That is G by D ratio. That is not GD by GI ratio. That is.
I just read the question.
Whatever. Yeah, I have seen this, sir. This Asuni ji is asking. So this G by D ratio is only calculating by the your peak intensity, whatever you have seen, that the peak between the G by D. That G peaks is generated by the inline vibration of the atom, and G is generated by the outline vibration of the atom, and D peaks is generated inside that the inline vibration of the atom. So whatever the peak intensity it is there, so in that way we just calculate the G by D ratio, and that is also known as the sp2 by sp3 ratio. I think no further question. I hope
I think maybe one or two.
Yeah, you can study the hydrophobicity for surface engineering and surface roughness by the goniometer. So when you generate, develop some new coating, then you don't know what is the surface energy. So if your surface energy is more, means your friction coefficient is also more. So we need the less surface energy, and so we can improve the nature of the surface. And also surface energy you can calculate it by the 3 method which is given: Jisman method, or this Young method is also there in the calculation of the surface energy, that in gonium, when you purchase the goniometer, or in net also it is available. Young's method, Jisman method, and one more method, I forgot that name, that is also used to calculate the surface energy. So we just need that particular gamma L, what is the angle of the liquid, what is the angle of that particular Young modulus in that particular case. So in that way we just calculate the surface energy, and surface contact angle is also very important to calculation of the surface energy. So contact angle is used to calculation of the surface energy, and your surface roughness also increase the hydrophobicity, but that surface roughness not more than optimum level. Otherwise it will not improve the appearance of the surface is also very poor after some time. So at least 1 micron it is sufficient. So that's why in thermal spray coating what you will do, you improve the somewhat, you can rougher the surface, and then diffusion is very good. So that's why it is necessary. And yeah, that sp2 by sp3 ratio gives you that particular defects present in that particular substrate, and what is the disorderedness of that, that is right. But this calculation is done by the intensity of those peaks whatever you have generated. So if that ratio is more, then it is not good, but ratio is approximately less, that is required in Raman. So Raman is basically performed in grease material.
So I think with this I can allow 1 or 2 participants to unmute yourself. You can raise your hand and unmute yourself, and you can have direct interaction with the speaker. If anybody is interested to ask any direct question to the speaker, I can allow 1 or 2. You can raise your hands and you can unmute yourself. I have allowed you to unmute yourself.
I hope all participants can understand better way all the things. That's why I choose the first day. So I thought that not go for the very hi-fi research, just go for the basics so that everybody can benefited by these characterization process and they can select the appropriate process in their research.
Definitely.
Yes, hello. Hello.
Yes, please.
Yes, I want to clarify just a little information regarding Raman spectroscopy. Basically, this technique is very not only used in Greece, but it can be used in many across different application or any sample. But this is more sensitive towards carbonaceous particles.
Yeah.
So yes, just I wanted to clarify only. Okay.
Yeah, that's true. You are true. That's why when we mix that particular, it can use, but most probably lubricant side, it is most used in that particular one. So if you
Yes,
are using carbon material like graphene, MWCNT or graphite in any compound, then you go for the Raman. It gives you the better insight that what is the formation of the component happened in after the tribological test.
Yeah, I think with this we have come to the end of our first session of our STTP series 4 surface characterization and treatments in tribology, and it is my honor and privilege to express our gratitude to Professor Jitendra Kumar Katiyar, presently working as an assistant professor at the Department of Mechanical Engineering, SRM Institute of Science and Technology, Tamil Nadu, for sharing his valuable experience, and still progressive research is going on in his lab in this area. And he particularly talked about some advanced characterization tools, especially the optical profilometer, then the Raman spectroscopy and the XPS. And he has given us an insight how we can utilize these equipments for tribological applications. So I think it was a good start for all of the participants. And today in morning, we had a very wonderful inauguration by Professor B.S. Murty, who is presently the director of Indian Institute of Technology, Hyderabad, who has actually given a very good insight on how we acquire our passion in doing research in materials, because that is very important. All these things, material science is the major part of tribology, and we are actually working on materials, and the response of different materials are what we are getting in tribology, and it is not at all a property, it is a system response. So according to the conditions, according to the environment, according to the other parameters, the coefficient of friction as well as the wear rate will vary, and the surface will deform or change with respect to the present condition. So it's very important to analyze the surface with very high importance, so that we can really know what will happen to our machine components. So once again, I thank Professor Jitendra Kumar Katiyar for sparing his valuable, I think he has joined at 9:30, now it's almost 12:15, for sparing his 3 hours today morning. And it's an honor, sir. And we will have more.
It's an honor to me also to share at least to all participants. And I hope 70% participants understood the importance of the characterization and different processes used in surface engineering. I think one person raised their hand. Just take that one quick comment.
Yeah, definitely. If somebody wants to speak, please unmute yourself and you can speak. Please, if somebody wants to speak, you can.
Somebody raised, I don't know.
Even me, I forgot his name. So
some Rajneesh, I also don't know. I just come and then go. Okay, no issue. If everybody understood, then it is a great privilege to me. If you have further, as a teacher, as a researcher, we always have the scope to improvement. If further I am happy if you tell to some feedback to me so that I can improve further for future aspects also, and hope we can further meet in this Tribology platform in any other institute or this institute, and we can further share our knowledge to you and others. Thank you very much, sir, to give me a chance to share my thoughts.
Thank you very much. So we are closing the first session of our series 4. In the afternoon, we are having another session, which is by Dr. D. Kesavan, who is presently the Assistant Professor of Department of Mechanical Engineering, Indian Institute of Technology, Palakkad. And he will be talking on the session, Tribological Behavior of PTA Deposited Hard-Facing Alloy. And Professor Jitendra in the morning has given us a wonderful introduction how we use different characterization tools in tribology, and in the coming lectures we will be going to the core part. And even though I have incorporated some basic lectures in the 6-day program in between, so that those who join lately can also understand, and the course is designed in such a fashion that every day people can get basic information as well as advanced information, especially in this field of surface engineering, which is quite interesting, and it has got a great relevance to the field of tribology also. And even myself, like what Jitendra sir has told, during our time when we did PhD, it is not that easy to get these sophisticated instruments, especially Raman spectroscopy, X-ray photon spectroscopy. Those were expensive equipments, and once we are in South, we don't have these equipments except maybe in IIT Madras or some Indian Institute of Science. Most of these tools don't have these kinds of instruments, but that is not the case in 2020. Nowadays, most of the labs, most of the good institutes are having sophisticated instruments, and we can see a lot of publications coming out of these instruments, especially this 3D optical profilometer, Raman spectroscopy, XPS. And nowadays, I think XPS is utilized routinely in tribology experiments, especially for lubricated studies, and even Raman spectroscopy to study the binding energy as well as the interaction of these additives in lubricants with the surface. So, I think the talk has enlightened as an opportunity to start new research on this particular area, and he has actually shown us some live photographs of where these equipments are available, especially the cladding machine, laser cladding machines, etc. So people can contact me or even Professor Jitendra Kumar Katya directly. He is having some instruments at his institutes, and you can also contact me. I can get you contacts of other STTP eminent speakers, so that you can utilize the facilities available in and around our country. So with this, and meanwhile, I have to say feedback form of our session 1 is shared in the chat box. You can fill that, and we are closing down the first session, and expect that all of you will join by 2:25 p.m. in the afternoon for the second session. It is it is from 2 to 4 p.m. So request all of you to join by 1:55. And regarding the PPT, so many people are asking. All the proceedings, all the PPTs, all the video recordings will be shared to all the participants once this FDP is over, and it will be shared through a Google Drive, like what we did in the previous 3 series. STTP proceedings, video recordings, then the photos which are taken, even the certificates will be shared through a Google Drive once we get through this 1-week program. Thank you, Jitendra Kumar sir.
Thank you, Dr. Chago sir, and all the best for your all future 5 days. 5 days to make a successful event.
Thank you.
Okay.
So feedback link is shared by Professor Philip Jacob. You can use utilize the feedback form. Feedback link is shared. Please utilize the feedback form, and
I will wait for a couple of minutes